Welcome back to the Deep Dive. Today we are focusing on what is really the backbone of our entire industrial infrastructure, the equipment that just never stops moving.
That's right.
We're talking about that critical, often totally unseen world of machinery that rotates.
Mhm.
Motors, pumps, these huge compressors, industrial fans.
And the stakes are just enormous. I mean, modern energy, manufacturing, even climate control, it all depends on these things running perfectly.
They absolutely are. And that's our mission for this deep dive. We've been looking at some really specialized research about the expertise needed to service and engineer all this rotating equipment.
Yeah, and this isn't just your run-of-the-mill maintenance. We're focusing this deep dive for you on the specialists, the players in sectors like oil and gas, heavy ag, where, reliability is just non-negotiable.
Exactly. So our goal is to give you a kind of blueprint. We want to understand the specific advanced technologies and the mechanical solutions these specialists use to troubleshoot, to analyze, and to fix problems at their root.
We're looking for how they get these massive quantifiable gains in reliability.
Right. This is high-stakes problem solving. It's
Yeah.
all designed to prevent catastrophic and incredibly expensive failures.
It's the difference between, say, replacing a $500,000 piece of equipment way too early or keeping it running at peak performance for decades.
Okay, so let's unpack this specialized approach. We've been looking at firms like Vibe.FX, and their core promise is genuinely impressive.
It is.
If it rotates, they claim they can troubleshoot it, balance it, align it, engineer it, analyze it, and fix it. I mean, that suggests a scope that's just way beyond your average maintenance team.
Well, it defines the scope perfectly. See, this isn't generalized upkeep, it's custom engineering.
Okay.
They specialize in finding a solution when the standard fix just isn't there, or maybe a problem has, stumped other teams for years. They're working at that boundary where they say impossible is just a challenge.
So when we say rotating equipment, that's a huge category. What exactly are we talking about here?
The breadth is really key to understand. Of course, you have the usual suspects, motors, fans, pumps, compressors, generators, but it also covers these highly specialized integrated systems.
Like what?
Think about industrial air-cooled heat exchangers. They are absolutely critical and heavy processing plants for managing heat, and if one of those fails, the whole production line can just stop. So if you own or operate any of these, you need this kind of expertise.
And what are the foundational competencies they're bringing to the table? I mean,
Yeah.
with list of services that comprehensive, where did they even start?
It all starts with the diagnosis, so the list really covers the full asset lifecycle. The core is troubleshooting and consulting. You have to figure out why it's failing first.
Which isn't always obvious, I'm guessing.
Not at all. And once you know the why, then you can move into the actual mechanical correction.
Yeah.
And these are the fundamentals: laser alignment and static and dynamic balancing.
Okay, let's pause on those two for a second. Laser alignment and balancing. They sound pretty basic, like Shop 101, but why are they so foundational for, major industrial gear?
Because precision is everything. Take laser alignment. We're talking about making sure two rotating shafts, let's say a motor and a pump, are perfectly coaxial.
Perfectly lined up.
Exactly. And even a tiny fraction of an inch off-center means the two components are constantly fighting each other. That unnecessary load is probably the single biggest cause of premature bearing failure and vibration.
So expert alignment just extends the life of the machine dramatically.
Right. It's all about reducing that internal stress.
And what about balancing? What's the difference between static and dynamic, and why does that matter so much?
Balancing is all about mass distribution. If a fan blade or, an impeller has uneven weight, it creates this enormous centrifugal force. We feel that as vibration.
Okay.
Static balancing is for things that are slow or narrow. You find the heavy spot in one plane and correct it. But dynamic balancing, that is essential for high-speed equipment, where an imbalance affects the component in multiple planes at once.
And you need special equipment for that.
Oh, absolutely. You need specialized gear to measure and correct that imbalance while the machine is running, minimizing vibration to, almost nothing. It's just non-negotiable for smooth operation.
This is where it gets really interesting for me. Moving beyond the fundamentals into high-tech diagnosis, how do these specialists use technology to get past, educated guesswork and actually reduce downtime?
This is their technical advantage, and it's massive. If you can definitively prove what is moving and how it's failing, you can shortcut weeks of labor.
And avoid replacing the wrong parts.
Exactly. The foundational diagnostic service they mention is, of course, vibration analysis. That measures the frequency and amplitude of movement to diagnose bearing wear or gear problems.
But the sources point to two other technologies that feel like a real leap forward. Let's talk about motion amplification. That sounds like something out of science fiction.
It is a game changer. It's a specialized video technology that does, well, exactly what the name suggests. It lets technicians see movement that is completely invisible to the naked eye.
How does that work?
They film the equipment at a really high speed, and then this proprietary software processes the video, magnifying micro movements, sometimes by a factor of hundreds, even thousands, and plays it back in a slow motion loop you can actually see.
So instead of just looking at a squiggly line on a graph that says, something's loose at 30 hertz, you can literally see the foundation base rocking back and forth.
Precisely. It just removes all the ambiguity. Imagine trying to fix a leak based only on a pressure drop reading versus actually seeing the water spray out.
Right.
Motion amplification gives you that visual certainty. It can take root cause analysis from days down to minutes because the entire team can look at the same video and agree on the exact mechanical weakness.
And that instant visualization must be invaluable for justifying major repairs, especially if the problem is structural. That's a much bigger capital expense than just a new part.
Absolutely. The third key tool they cite is infrared thermography. This uses special cameras to map out heat signatures.
So you can see hot spots?
Instantly. You can spot failing bearings running hot, identify subtle electrical faults before they become fires, or, and this is critical, evaluate the efficiency of heat exchangers. You see exactly where heat isn't being transferred properly.
So you combine foundational vibration analysis with high-tech visualization, like motion amplification and thermal diagnostics, and you get this complete multi-layer picture of machine health.
Right, and that picture then informs those customized maintenance plans. You're making sure you address the root cause, not just the symptom.
Okay, so once the diagnosis is done, you still need perfect execution. This brings us to installation integrity.
And asset lifecycle management, exactly.
True reliability starts before you even flip the switch. The sources highlight this deep expertise in major industrial installations, pumps, compressors, that kind of thing. What's the biggest installation mistake these experts are trying to prevent?
It almost always comes down to the foundation, or what we call base plate stability. Yeah. The sources specifically call out expert alignment and grouting as essential. Everyone thinks of the pump as the expensive part, but if the foundation isn't perfect, that pump is going to struggle for its entire life.
Grouting just sounds like concrete work. Why is that considered specialized expertise right alongside laser alignment?
Because it's not concrete. It's a high-strength, usually epoxy-based structural cement. It's designed specifically to fill the tiny gap between the concrete foundation and the metal base plate of the equipment.
And if that fails?
If that grout fails, or if it was installed wrong, with voids or cracks, the base plate can flex or twist under load. That shifting leads you right back to misalignment and, well, catastrophic vibration.
So if the structural anchor is weak, everything else, the perfect alignment, the balancing, it's all going to fail eventually. It's a mechanical domino effect.
Exactly. And as we'll see in the case studies, having the knowledge to correct years-old pump installations, including repairing bases and regrouting, is a huge part of what sets these experts apart.
So they fix the mistakes of the past.
To secure future performance, yeah.
And beyond just the hardware, these complex projects need serious coordination. The sources talk about structured support services like project management.
Well, when you're dealing with a plant turnaround or a big new installation, coordination is half the battle. They offer planning and scheduling services just for that, to reduce delays. And then at the very end, there's the critical commissioning and startup,
which makes sure the equipment operates exactly to spec from day one, minimizing that initial super high-risk period.
And if we connect this whole approach to future-proofing, we have to talk about predictive maintenance and AI.
Right. Perfect mechanics is step one, but continuous monitoring is step two. How does AI help with equipment that's already supposed to be perfectly aligned?
It acts like a continuous expert auditor. The platform uses AI to analyze real-time behavior vibration trends, temperature data, and compares it against its own learned failure patterns.
It's looking for the tiniest deviation.
The earliest possible one. So instead of waiting for a manual check or a small spike that someone might miss, the system suggests interventions based on what it's learned. It moves you from preventative to truly predictive.
It helps management decide, we need to fix this bearing next Tuesday, not after it becomes a crisis.
That's the idea.
All right, now for the part that really matters to the bottom line, The proof. All this specialization, this high-tech analysis, what does it actually translate to? We need the tangible results.
And this is where the case studies and the sources become really compelling. The measurable results are stunning.
Where should we start?
Let's start with thermal efficiency, especially with industrial air coolers and fans. Keeping operating temps cool is crucial for production capacity.
The case study from HOG Tucker Thermal is a perfect example of this. Randy Peterson noted that after they installed new inlet bills on the cooling gear, their operations did not have to cut production during peak heat around 34 degrees Celsius.
And that contrast is the entire point. Before this fix, when it was actually a bit cooler, only 30 or 31 Celsius, they had to cut production because the coolers couldn't handle the load.
So this intervention let them maintain full output during the hottest, most profitable part of the year. That's a direct revenue protection win.
Huge. And the performance metrics for fan projects get even more extreme with the TC Energy work. Quinton North highlighted projects where, after optimization, the outlet gas temperature reduction was somewhere between an astonishing 20 and 24 degrees Celsius lower than any prior upgrade.
Wait, 20 to 24 degrees? That's a massive drop in an industrial process.
It's absolutely massive. It means the equipment is running dramatically more efficiently, using less energy, extending the life of the compressor, and potentially increasing throughput by hundreds of barrels a day. The efficiency gain isn't marginal, it's transformational.
And we saw something similar at CDU Production Engineering. Paul Emberton reported their approach temp was down 5 degrees, and even though the ambient air temperature had gone up by 10 degrees, their cooler bundles were running much closer to full capacity.
Right. That shows they didn't just fix a problem, they redesigned the performance. The efficiency improved dramatically even when the outside conditions were actively working against them.
Okay, but let's zoom in on the specific financial impact, because this next number is so specific and it really just underscores the value here. Tell us about the work at the Strathcona refinery.
So this was a project with a mix of fundamental fixes. Adjusting manual fan pitch, cleaning the air side, tower adjustments, and the source notes that while the exact impact of each piece wasn't documented separately,
It's a holistic fix.
it was, but the cumulative result was just staggering. These combined changes led to a verifiable flare reduction estimate of $270,000 per year.
Hold on. $250,000 saved annually from optimizing fans and making sure things were adjusted and clean. That is a phenomenal return on investment.
It suggests the cost of the service pays for itself several times over, almost instantly. It just proves that industrial efficiency is found in the details. You don't always need to rebuild the whole plant.
You just need surgical precision on the assets you already have.
Exactly.
What's fascinating is that this isn't just about high-tech thermal stuff. The sources keep bringing us back to foundational mechanics, like the grouting we talked about earlier.
Absolutely. Drew Bonin from Gibson Energy and Quinton North from TC Energy both emphasized that the reports and the execution included mastering those fundamentals. Drew Bonin specifically called out the knowledge and experience needed to perform corrective actions on years-old pump installations, including repairing bases and, critically, fixing that failed grouting.
So on one hand, you've got AI integration and high-speed motion amplification. And on the other, you have these highly skilled millwrights repairing foundational grouting that was installed decades ago.
And the lesson is clear. True expertise has to master both, the cutting edge and the durable fundamentals.
It seems like the specialist team has to be made up of both expert mechanical engineers and these highly skilled millwrights who are just as comfortable with a laser alignment tool as they are with an epoxy grout mixture.
That's it. You need both.
So this deep dive has really shown us that peak industrial performance isn't about luck. It is a deliberate strategy. The core takeaway for you is this: specialized high-tech diagnostics, like the visual certainty of motion amplification, has to be fused with that foundational mechanical expertise.
Expert grouting, balancing, alignment, that combination is what achieves these massive quantifiable gains.
And the sources emphasize that these stunning results, the 24-degree temperature drops, the $270,000 annual savings, they aren't just a function of the tools, it's about the culture.
Right. They attribute the success to core values: honesty, integrity, and delivery. This human element, this team of professionals who are described as, quote, relentless in finding solutions, that's what enables the impossible to just become another challenge.
Which leads us to our final thought for you to chew on. We've seen specific examples today of how seemingly minor specialized engineering improvements, like a fan pitch adjustment or fixing old grouting, can save $250,000 a year.
And keep production running during a 34-degree heat wave.
Exactly. So if a 20 to 24-degree temperature drop is possible, just with optimized fan blades and a proper installation, what seemingly minor piece of rotating equipment in your operation holds the potential for the biggest, most overlooked efficiency gain.
Take a moment to consider where the weakest foundation or the slightest misalignment might be hiding your next big operational win.
Something to think about the next time you hear a motor hum. Thanks for diving deep with us. We'll catch you next time.